Still stuck, right?
We need customers like that.
One of the interesting things is in our shop, we pull mouthpieces for free. And then usually they come in that way, and we pull the mouthpiece out for free, and that brace is $16, and that brace is $20, and it's $150. Thank you. Next time we pull mouthpiece for free. Anyway, it's just a little fun thing that we put together for you all. Thank you so much for coming. What a thrill to be here. My wife and I have been up north in Port Douglas, Sydney and Port Douglas for a few days, and what a beautiful opportunity to see your great country. My voice is a bit raspy, so can you hear me? We'll see how this goes by Sunday afternoon when I'm doing the forum for Bill Sunday afternoon instead of the other clinic that got switched around. So that'll be a lot of fun. But what an awesome opportunity that you guys have to get together. We do this in the States, the United States, and we have about 300 technicians get together and do this, and it's just an awesome opportunity, a great time to learn in the hallways, in the clinic rooms, at the bar at night. It's an awesome opportunity to share and learn and have that camaraderie that goes along. So we're going to. How many of you took the time to look at the PDF? Okay, I put this together, this clinic together about 1997 was when I first did this clinic, and I always have copies of everything, and I could not find the original documents, but I knew a guy who had one, and he scanned it for me, and anyway, so we got the documents back. The pink safety glasses, it's a prerequisite in California that you have to wear pink safety glasses, right? My black one's broken. These are the only ones that I could bring with me. One of the most important things that I want to talk about is shop safety. In my shop, if you go to the solder bench without your safety glasses, likely you're going to get sent home for the day. I don't tolerate people going to the solder bench without proper protection, or going into the chemicals, going into the ultrasonic cleaning and such. We have to wear safety glasses. We only get one set of eyes, one set of ears. So I always preach shop safety, that's such a critical thing. Just a little demographics. How many of you been repairing more than 5 years? Okay. More than 10? More than 20? More than 30? Doggone, you're old. How long?
What's that?
How long?
How long? Going on about, coming up to 37
Yeah.
years. Yeah.
I've got about 38 years doing this. I've done that a couple of times in the large snapper conventions in the States, and there's one guy that keeps showing up, Bob Fleming, and he's been doing this for almost 70 years.
Wow.
You worked it out yet?
He goes in and he works about 3, maybe 4 hours a day, a couple of days a week. He says it gives his wife time to do something. So anyway, so that's what it's always fun to know. When I asked for a fireproof or a fire-resistant platform to solder on, the garbage can was the best thing. So here we go. Want to talk about the pieces and parts. Come on in, find a chair. I don't bite you can sit right in the front, wherever you like. Pieces and parts. We always have the trombone slide, and it was interesting. There was the flight attendant on 15-hour flight here, you do what? That's a thing? You actually, there's more than one part to a trombone slide? Well, yeah, there's a baggie of parts and some tubes. The fine folks at the airline decided to rearrange the ends of some of my tubes here. So it's interesting to ship stuff, to bring stuff into, you know, on the airplane. They definitely tend to investigate what's in your bags. This is a mounting glass. It's just a flat piece of glass mounted in a. I got pulled aside, and they decided that needed a second look. The tubes, they didn't care about the brass tubes.
Oh, the glass and the tubes.
Yeah, that's right. Anyway, so it's fun to get to go through the exciting part, getting all this debris here. Anyway, nomenclature, so that we all have a healthy dose of, you know, what it is that we're talking about. In the handout, I'm going to save that little screw because I'm going to need it, and I don't want to have to crawl around on the floor to find it. So I'm just going to go through the name the parts that I'm going to talk about, just so that we all have, you know, you all call things different, you know, cutlery instead of forks and knives, you know, things like that. This is the upper cork barrel, and if you need, that's for the next clinic. I brought 2 sets of slides so that I didn't have to take this one apart in the middle. So you can pass that on around, and just as long as all the pieces come back. Because a trombone slide with 99% of the pieces, yeah. So just the upper cork barrel. Slide lock ring, which is the little ring locks the slide. Identify it before I step on it. And then the slide lock lug. And then I'm just trying to read how I have them listed. Do you have anybody following along? They've got the upper inner tubes, which are the chrome plated tubes. Any reason why we use chrome? Does anybody know why?
Slippery, hard?
Super hard. One of the hardest platings that you can come up with. And if it's prepared properly, the chrome plating is very slippery. And then the venturi, some people call it a mouth pipe. And that's what actually gives a resistance to the instrument. The instruments really are very squirrely without a mouth pipe or venturi. Please, if you have questions, call out and we'll first point and laugh and make fun of you. But so that's for the inner upper, and then you've got the brace section, 3-piece brace section that goes together to hold the whole inner section together. From there, we're going to go to the outer section. Outer tubes. On some, there are rings along the top. Go to the ferrules, connect the crook, and that's the part I'm looking for. There it is. And then there's the water key, nipple, saddle, key, the end guard, and then the brace section to hold the lower end together. So, we're going to build the outer slide first. That's the way that everything, the inner slide is matched in span and scope to the outer slide. So we always start with the main platform. That's the other part selection. Do do you guys measure things in thousandths of inch here or in bore size? How do you measure your millimeters? Okay, so in America, 0.500 is half inch. So what is that in your world here? So the there's four main bore sizes in the trombones, and that's the 500 bore, 525, 0.525, 0.547, and then into your bass trombone, which is 562, 572. You can do all the math on that. It's multiply it by 25.4 or 24.5. So that's your multiplier. The part selection when you're matching tubes. If you're going to fabricate a complete slide, or if you're going to fabricate a portion of the slide, have to replace a main, an outer tube, something. There are times in the shop where you only need to replace one tube, as opposed to manufacturing an entire slide. So this still can apply to that situation. Bore size, and I hope I'm not too elementary or basic, but I figure I should cover the bases early. Standard set of calipers. Bore size is measured on the interior of the slide tubes.
Is it taken at the foot or the other end?
If you're measuring for the instrument at the top of the lower slide where it goes into the bell, that's the most critical measurement. That's where you're going to find, unless you have a dual bore.
Yeah.
Of course, they're going to throw something in to make it more exciting. So on the dual bore instruments, you need to take it in both places. Like the King 2B or the Getson 540 to 525 has the dual bore, the 525, 547. What are the main brands that you all work on down here? Edwards.
Right.
Mm-hmm. You guys get into any of the JP stuff yet?
Some.
Some of it. The Salvation Army based JP. That's where a lot of that goes. And when these parts were taken apart and prepped, they didn't get them scraped out. This slide assembly's been together 5 or 6 times, so it's
Still not right.
I keep having to do it over. One of these days I'll actually try and get it right, buff and lacquer it, and get on to getting paid. Okay. So I'm going to move the inner slide stuff out. Outer slide stuff here. How many of you ever do this kind of work? Slide replacements and such? Yeah, nice. The part selection, what's the difference that you need between the inner and outer slides for the appropriate seal, so that you have a compression, but yeah, it needs to move. Depends on which manufacturer you talk to. Yamaha builds them very tight. Yamaha builds them at about 7 thousandths difference between the stocking of the inner tube and the outer tube ID. 7 thousandths, that gives you about 3.5 thousandths on either side, as long as everything is straight and round. That's really tight. I have seen them come from manufacturers as loose as 18 thousandths. And then you put your slide up and it goes, no compression at all. So, typically somewhere in that 8 to 12 thousandths is what most manufacturers want in their gap between their tubes. Do you all get your parts from Allied Supply? Where do you all get your parts? In the Allied book, they've got a real nice comparison chart. If you're going to get that tube, that one makes it. That's a really great resource. And Bob Getson, the founder of Allied and the Allied Repair School and all that, when I was going to school there, he was always talking about how much effort they put into that catalog, and that use the catalog as your main resource for all of your information. And it's been quite helpful over the years. So slide tubes, when you order, when they come raw, their length they're too long. Right? Have you all seen that? When you order a slide tube, they come in about 5-6 inches too long. And when you put your trombone together, it plays in A. And then it's a Canadian. Tough crowd. My manager in my store is Canadian, so we're always full of jokes and difficulty for him.
We did that about New Zealand this year. New Zealanders, they're Canadian.
Yeah.
Canadian, they're your Canadian.
So you take the train, eh? Yeah. Same response at home. So, when you cut your slide tubes, you can use, I have a really fancy new tool, and it's so awesome. It's a little miniature chop saw, little pivoting chop saw. And I do all kinds of crazy main tuning slide trigger fabrications for all of these crazy tuba players, and so I'm cutting up bits and little tiny pieces, and I used to do it all with a jeweler's saw in my hand, and hours and hours and hours of stroking it out and trying to get them all straight and square and all that, and then I got a chop saw, and oh man, that's cool. Tubing cutter, are you familiar with this type of tubing cutter? All these tubes are cut, so you can pass that around. I didn't bring my chop saw.
Why not?
Because you only get 50 pounds. And I had to take some of my clothes and put it in my wife's suitcase so that they didn't take.
So what diameter is that saw?
The saw is a 3 1/4 inch blade.
Okay.
And it came from micromark.com, and it was $265 US. But I'll tell you, the first time that I used it, I was in the middle of one of those big fabrication jobs, and I've got some video of those if you want to see them. I saved, I'd say probably 5 hours in fabrication time. Was it worth it? On one job, I paid for the saw. You know, it was absolutely the right thing to do. So, I'm a large proponent of using the correct tools. And if there's a tool that will make the job go faster, buy the tool. Even if you only think that you're going to use it once, the time savings, and you'll do it again. You will use them more than once. So that's really a thrill to get to buy the correct tools and save that much time on each job. I can't tell you how many times I've broken dozens and dozens of saw blades and saw blades and saw blades. I'm still, I'm only half done, and then you have to file and square and straight. But this way, with that saw, your jobs look snappier. They look much cleaner edges, squarer, straighter. It's very cool. Yes, sir.
When you say a chop saw, that's not our terminology. Is it a saw, like a bracelet cut-off wheel, that has a vice and a blade, or is it just a nail grinding?
It's a circular wheel
Yeah.
that would come on a pivot from the back and rotate and go through.
Like a bracelet cut-off.
It's actually a carbide tipped tooth blade. It's not an abrasive wheel, but a carbide tipped tooth wheel, which will cut your non-ferrous materials, nickel, brass, any woods, of course. And you just have to go slow when you're going through the more dimensional brass. These tubes, when you chop through them, just goes right down through it, very clean, square flat ends. That's very cool. So once you've cut the tube off, if you're going to use that other style of plumbing tube cutter, it will tend to pinch the ends of your slide tubes. Obviously, we have to address that. I have a pair of pliers that I've fabricated or modified that is radiused on each end. I'll pass them around just a second. And you can come in and squeeze it and go round and round and round, and it makes the slide tubes round again. And so, but that's and when I put them in my suitcase, they didn't have rust on them, and now they do. So, but when you cut those slide tubes, it tends to pinch it in. You have to relieve that so that one, you don't change the bore size, and two, that your parts fit together properly. Any questions? Please holler out. Then you have your ferrules. I'm a large proponent of the ferrules fitting fairly snugly. The idea when you're doing this is if it can be supporting itself while you're soldering, you have taken the need for 4 more hands out. And since I only have 2, it works out better that way. Before those get too far. There we go. I actually need to reduce the size of this. This tube is flared just a touch too much, so I'm going to reduce the size of it. It does both. It'll make it take the interior back to square. It'll also bring the exterior back to square with this set of pliers.
How are you reducing? Are you reducing?
Yeah, I'm reducing the flare of that.
Oh, it's a flare, right.
There has to be a certain tension to the interior of the ferrule.
Yeah.
And this was a little too much.
Yeah. Are you slightly pulling it?
So
Like if you want
when
to
you're
expand it, would you pull it up a little?
Nope. It's just the way that this pair of pliers works. You just go right along, and it will square the end of the tube. What I'll do is I will. Okay, guys. I got to do this clinic a second time, so don't damage these. But I will send a slide around so that you can feel how it. So you can. Those will catch up to the other. Just change one of these. 611. Thank you. Yes. Which one did I set? Oh, be sure I get the right set of tools together. Okay, so the ferrules, I like to have them with a fairly snug fit. That's so that it's stable in place. The question is it a stepped ferrule or is it a regular or a standard straight ferrule? A lot of the ferrules are stepped because of the thickness difference between the slide tubes and the hook. And there was a gentleman who brought me all the goodies. There was a base here for this torch to stand up. How many of you use liquid flux versus paste flux? liquid flux? Anybody using paste flux?
Oh, no.
Not for soft solder?
Yeah.
In the hard solder, the silver solder?
Scott,
Yes.
can you get the exact correct length of the outer?
The correct length of the outer tube?
Yeah, just tell us it's all.
The cool part is if you have the old tube. That's really cool. If not, you can measure the overall length of the instrument. And there's a, the formula is the frequency of the fundamental. And typically we only hear the octave. So the fundamental of a trombone is not the bottom of the bass clef line, it's the octave below that is the fundamental. The length of that is calculable. Hopefully you would have an old tube or a mate somewhere along the way in the shop. But I've had to do the calculations on a couple of horns. I had one crazy King bass trombone that I ordered tubes from King. They came in, I soldered together, sent it out to be lacquered because the guy wanted to put a particular lacquer on it. Came back in, it wouldn't go in the case. King had told me they were trimmed tubes. I didn't check. So I had to go cut the lacquer on the ferrule, go cut the tube off, calculate the total length of the tube, because they wouldn't tell me. King wouldn't tell me, so I calculated the length of it. And then,
Why wouldn't they tell you?
secret. Proprietary information. Really? How many of these things are floating around there? Come on, proprietary?
They're obviously not part of network, they're not part of.
Yeah. Well, at that point, there was some animosity between Consumer and Knapford. So, hopefully you would use an existing tube, but more than that, it's you can calculate it. And if you email me, I can get you the formula. It's not hard to find. And the government really doesn't like me, or the airplanes don't like sending flux acid in the plane. So the gentleman brought me a pint. It's really cool. And typically we use an oil bottle. A needle oiling bottle is what I like in my shop, so that you can squeeze it and then release that as you tip it over. So there's a vacuum pulling the flux up into the bottle until you get to your spot. And then all you do is compress the sides or stop the vacuum, and you get one drop of flux out. And that's cool. Let's see. And of course, the exciting part of all this is heat control. And of course, they're unlacquered tubes, so I can you'll put the heat to it, and it works out just right. The solder, and actually one of these glasses is not for me to drink. One of these glasses is to rinse. I typically tend to do all of the soldering and then wipe later to wipe up the excess solder. And the solder, on my torch like this at home, I ripped all the safety devices off. That was just no way was that gonna last. What I'm doing is I'm just seeing how this stuff is gonna react. See if the solder flows differently down here under the ocean.
Goes the opposite direction.
I still have not seen whether the water goes the other way. Okay. Come back. And of course, none of you ever drop anything on your okay. If I need to adjust the contact point where I need a little more contact, the other set of pliers does a nice job bringing it in. It'll also open it up slightly. This one I need a little greater flare. Just a standard tapered pair of high quality needle nose. And really what I'm after here is just the tip of that to open up to hold on to the ferrule just a little bit more snugly. And the whole goal is to do that so that it's not too far, and then you have to get the other pair of pliers, right? Yes, there was a question back there. No?
So those pliers will clean up the mess that the pipe cutter does? Because it's quite severe, isn't it?
Yeah, it can be, yeah. I like, I'm supposed to have, you've all seen the new ones of those, right? That's almost 40 years old. And if my children were here, they would all say, oh, you're old. It's true. Okay, we'll see how this goes now. And Kurt Alterac was kind enough to afford me this flux here and the brush top. The whole entirety of solder work is heat control, and that's something that if you'll follow direction of your flame, one of the cool things if you ever have turned off the lights and seen how long the flames are. When you have this flame here, the looks about that long, but the totality of the flame is about this long. And I don't know if you can see it or not, but the tip of that flame is right out here. And so that's, and of course the hottest spot is at the peak of that pencil tip. Okay. Again, I don't want to be too basic, but if I don't say something, it's what are the, how many of you get to solder on the pull knob on the second slide? Yeah. How many of you get to wipe the solder, the excess solder off? It can be done actually, and it's all based in heat control. The direction of your flame and how that flame is pointed or directed past and allow the heat to dissipate into the edge of the solder. There's 3 levels of on your solder. There's 3 states of solder, right? We have a solid state, which is what this is. You have a plastic state, and then you have a liquid state. The whole idea is that we always want to work in that plastic state. When it gets to liquid, it's uncontrollable, and it just goes wherever it will. So we want to work in the plastic state. Does that make sense? Ed Krause, you all do Ed Krause's stuff? How many of you ever met Ed Krause? He's quite a character. Say again.
Frankfurt Music Fair.
Oh yeah, he goes to Frankfurt all the time. Ed and I are good friends. We talk about each other all the time. So now comes installing the main hand slide crook. Be sure so we keep the sets of tubes separate, because otherwise I'll wonder why they don't fit together. slide tube, the crook needs to be slightly enlarged to fit these ferrules. It just needs to hold itself up, right? It doesn't have to be tight, it just has to hold itself, because when I'm going to mount it, I don't want it to sag, right? So it needs to be snug enough to go together here. And of course, in the notes, or all of this is very detailed. I have it nicely detailed out for you.
Is there that solvent that you're using? What's the consistency?
This is a 50-50 solder. Yeah, 50% tin, 50% lead. And
Do you use that on everything?
No, we use, we still can, I don't know, do you guys get to use tin lead solder? Yeah. There's a movement to take tin lead away from us, to take the lead, to go lead-free solder. Okay. Yes, we can solder with the lead-free solder, the cadmium-based solder, but then you're, can't hear.
You used to put it in petrol lead, now they want to take it completely.
Yeah. So if you take the lead out of solder, you put cadmium in, and now you have cadmium poisoning, right? So the lead in musical instruments, we have no contact, or no real potential contact, unless you're out licking the inside of your instrument. And, you know, if that's your thing, have a good time. So the question is where to put the brace. Where along this do you put the brace? And if you're in elementary school band, where that brace is at your bell is where third position is, right? Until you catch the back of your fingernail on the way up and it tears it off, and then you don't do that anymore. So where do you put that brace? And the answer is in the cork barrels. The cork barrel with the lock ring in place. And whatever that total length is really what's going to matter. Okay. So off of the inside slide, and then the way that this comes in, there has to be your bumpers up at the top. Right? We're going to install it with that dimension in mind. We're going to put that in there like that, where that is, where the tip of that lock ring sits, minus about 3/16 of an inch. So we have a cork bumper at the top. It's really not that precise, and it depends on how many of those bumpers that you want in there. But that's typically on your main tuning slide up here. It's in tune out about 3/4 of an inch, so there is some variability there. That if this is out of, not in the exact original factory position by 1/8 of an inch, nobody cares. It really doesn't matter because there's enough variability built into the instrument. But that's if you are fabricating raw and you don't have an old mark on the instrument, you can get it from your cork barrel. Put it on there, measure the depth, score your line. When I do the assemblies on these, and it's been in practice this way, except for a few exceptions, like the Yamaha 2-piece brace instead of a 3-piece brace, right? The 2-piece brace is adjusted to the lower side. All of the other instruments are always fabricated with the brace solid in the bottom, and the upper side, the upper slide, is where all of your adjustment happens. All of the other manufacturers do it that way. Yamaha, and then of course there was the Olds Ambassador had the 2-piece, and that was just a simple slide. And then the old Super, you guys see any of those, the older Olds material? They're actually a 1-piece brace. This is a 1-piece. So the question is, how do you adjust the span so that the tubes lay parallel, right? So on those, the crook is what's adjusted. This is a solid piece, it goes in place, and then to adjust the parallel nature of the tubes, you you adjust the crook span, and that's how you get these tubes to be parallel.
Just by bending it, or
Uh-huh.
is there, all right.
Yeah, you just take the crook and
Yeah, they
bend it in and out, and that was Zig Canstel. How many are familiar with Ziggy? He's getting very, very old. A friend of mine, I talk to him occasionally, and grumpy old man, and he'll give you the shirt off his back. He's a super guy. But I said, you know, really, you want us just to go bend that crook? He said, yes. Okay. He was quite grumpy about it. Okay. Whatever clamps you use, these particular ones, I like these. These are Furry's E45A is the clamp that I like on this particular style of material.
What?
I brought 6.
So do you bend it first before you solder it, or?
Bend which?
When you have to bend that, what's it called?
The crook so when you're when it comes time to make these parallel on a slide tube on an adjustable 3-piece, we're going to install one side solid on the lower. Okay, and I'm working on this platform. This is the lower towards me, and the upper is towards you. Okay. So what I've done is I've clamped this.
And if it's a one piece?
I'll show you in just a second. Okay, and the reason that the depth of this brace matters here is so that when you come up to the lock, that there's room for the lock to go around, right? So that you're not pinching the assembly together. Okay, we'll see how this. Whoa, we got fire. And so what I'm going to do here is solder the lower brace. An interesting phenomenon here when you solder different thickness materials. So what you'll not be able to see so far away is I'm dropping the solder in and then pulling it all the way around to the backside. Solder will always flow to the hottest spot, right? If you want the solder to flow to a hot spot, put flux there, and the solder will flow there, even if it's not under the joint. If you're out in the middle of the tube, the solder will go right out there. You know, we get to solder plate things, right? Okay, at the same time, I'm going to solder the lower side of the brace tube. If this were a one-piece brace, I would get the span clamped in place. Come up below the stocking material here, right? This upper end stocking. We are familiar with what I'm talking about, the stocking on the end. Not everybody's shaking their head yes. Is everybody okay? Okay. Below that stocking, I'm going to take a measurement. Come down here. If this is different, I'm going to adjust it in and out to come bend that crook in and out.
Do you solder 1 foot on and then you adjust that, or you do?
On the 3-piece side, on the 3-piece
yeah.
one. On the 1-piece, I just clamp the 1 piece in place.
Just clamp it.
And then we're going to get a gross measurement. We're going to come in and get it fairly close. This takes a little bit of finagle to get it back and forth, right? So it's important that you get it close, and then we can solder it. start to solder it and narrow it down so that we get it accurate. Okay. So on this one, before I do any solder work down there, I've got one leg soldered together up here. That's only 2.731. And this crook is 2.775. So I'm going to open this up. .80. When I change the trajectory up here, it grows down here. There are a couple of jigging platforms that are out and available. The Furries has the magnetic bases that you have, magnetic strips that you place on top of it, or steel strips, and then magnets that are wedged cones that you can come adjust it. I actually choose not to use those for a very specific reason that we'll get to in just a second. But I really do prefer this method, and as a matter of fact, Holton changed the way that they started fabricating slides after I talked with Jim Stella, who was their Trombone plant manager. And he said, well, that's why we're always out of square by about 6 to 8 thousandths of an inch. And we'll get to that in just a second. Now I'm going to get it close, but we're short on time, so I'm not going to get it perfect. I typically come in and get it within about 1.5 to 2 thousandths of an inch. Okay. This, before I do that, got to be sure that the slide tubes are the right length, right? That they're the same length up on this end. I just use a flat file, right? You put it up against the end of one tube, and as long as it's cut off square, it's good. But you have to come up and be sure that they're the right length. Okay, that's adjusted there. Here's where I choose a little different approach. I'm going to solder the brace tube of the three-piece brace. I'm going to solder the brace tube before I solder the outside flange. Okay, and I'll tell you why as we get going. The thermal expansion of these tubes, when you come in and get it all up to solder temperature, the thermal expansion actually comes up at about 12 to 18 thousandths of an inch in length. That brace tube, that center piece, will change length by about 18 thousandths of an inch as you heat it to solder temperature. Now, the plastic state of solder comes in at about 427 degrees. Thermal expansion happens at about 290 to 300 degrees. So it's hot enough to be lengthened. You put your solder in, the solder cools, and then it shortens. So does that make sense? So Holton actually was not, they had mounted their stuff all in jigs, soldered it all, the braces got long, and then they cooled them, and their slides were narrow. They did that for years.
They're not alone. I come across that.
Exactly.
Lots of manufacturers all the
Exactly.
time.
So I put it together this way so that I can cool this. And I have spray bottles in my shop. And once everybody says you never quench solder, you never cool them with until when it quenches it out. If the solder is in plastic state and you spray it or cool it with water, it will create bubbles, oxygen bubbles in the solder, and you have no strength at all. You can literally just twist it and it'll come apart. If you allow it to cool from plastic into solid, I don't care how fast you cool it, it doesn't matter. So
I always thought it was it always affected the integrity of the joint.
And if the solder is plastic or liquid and you cool it, I guarantee it will affect the integrity of the joint 100%. Literally, you just go break them and look at them, and you can see all the bubbles of gray on the surface of the solder. They're little tiny bubbles. So once it gets back past plastic into solid, cool it down. Cool it down. So now that this is cooled back down, I'm going to solder the outside. No, honest. And in the meantime, I would come back and make it square and straight, check and check and check and check. Now before I solder this all the way, I'm just going to tack it. I'm just going to come out and give it a light tack, just so that it's semi-stable. And of course, I'm heating the thicker part first, right? Just a light tack, I just need it to stay still for just a second. Get it close. And again, I would fuss with it to get it about 1.5 to 2/1000ths of an inch out of square is my total acceptable move. Now, with this, I need it to, that's why I tightened that crook. I need to get down and look, see that it's flat. It's nothing worse than a pouty trombone slide. It's got its lip hanging down so that you're playing and it goes around the corner.
Doing this in your shop, once all the slides prepped and clean, and blah, 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 but fully disassembled, how long roughly does it take you to fully assemble and align?
To do this whole job from raw stock to a soldered, not buffed and lacquered, 35 to 50 minutes, depending on how complex the job is. But the quickest slide I've ever built was about 30 minutes. And those, I knew the slide tubes were the right length and it just went together.
Yep.
Yeah. And of course, I'm being ultra careful and putting the solder only where I want it because we have all day to get it done, right? And one of the reasons I like mounting on the glass, or I have at my shop, I have a granite, about a 3.5 inch thick piece of granite that's been milled flat. That's hanging over the ends. You can draw your solder, do all your work without having any bench contact. It's important that you remember the stocking line and keep it off of your mounting platform, right? Because it changes the way that it sits. Right? So that's soldered, that's tacked. I would come back, check the span again, be sure that we're right exactly where I want it.
How would you adjust it?
How would I adjust it now?
How would you adjust it if you need to?
I would come out and reheat the center joint on the top end.
Yeah.
I would reheat that, adjust that, and then let it cool back down, and then come back, recheck it, be sure I'm spot on. I mean, it really has to be within that couple thousandths of an inch for the perfect slide action. So now, the reason I do this is I want that brace length to not change. Okay, so now I'm going to come, and if I've done any adjustment, this will have a little click. It's going to settle. And then I'm just going to go ahead and solder this. And the whole idea is this little tiny flange is all that's hot, right? Back here, I'm not going to stick my tongue on it, but you know, I've got my finger on it. It's not hot, so I haven't reached that portion of thermal expansion on that tube length, which then goes and changes my span. Right? So, it's not a lot of work to put it together. Now you have to do all the extra stuff. And I actually do all of the soldering first. And then come back and do the wiping and cleaning. The guard, flex it so that it matches the contour. It needs to be centered left to right and up and down. You actually gotta get down there and look. If you don't get down there and look, I guarantee it's down just slightly. Gravity does pull it right on down.
So do you typically use a microtorch or use like a bigger?
I use two. I have a propane and atmosphere Gauss with a BP1 tip. It's about a 6,000 BTU tip, very small pencil flame, half inch. The 12,000 BTU tip is just too hot. It's just not controllable enough. The Gauss tip, I do use a microtorch like
They're
this.
quite handy because they're very light and maneuverable.
Right, yeah, and when I'm doing this kind of work, I reach for this. I really like the big torch for doing bell mounting or, you know, tuba disassembly kind of stuff. Now, of course, I'm soldering over there, I'm drawing it clean to the other end. So I have solder clear over here with 1 point entry. Again, it's hot enough to melt, continue to melt the flow, and I'm pulling with heat, because solder will always flow to the hottest spot, all the way to the other end of the and we'll wait a second until it cools down. There's a minor gap here. Now I'm actually heating the crook instead of the guard, because I don't want to heat the rest of the solder that's in the guard, right? So I'm only heating the one place, letting the heat dissipate in there to where I can fill the gap. Check the other side. It's completely sealed all the way around by doing it that way. Next part that I install is the water key nipple. In plumb position, it needs to be what's downhill, right? We don't want them. Seriously, guys, it needs to go on the bottom side.
Have you done it?
I've had a number of instruments come into our shop that somebody's replaced the crook. Yeah, it needs to be on this side, all right, on the downhill side.
So why is that? No, just joking.
The whole gravity thing, it's always getting me down, you know? Yeah, seriously, it has to be downhill. And again, you have to look. Is it square and straight? I'm not checking my phone, I'm actually checking the clock. We're at 3?
End at 3. Yeah.
Up and down, build the slide.
You got it.
Do you ever find that cold cream on any of your jobs?
Say again?
That cold cream that actually stops the heat from dissipating to another area?
You know, I've never had to. There are a number of heat creams and such that will stabilize those. There are. But it's all heat control. 100% heat control. And that's why I always have slit and turned that on. Little screw, assemble the water key. No spring, of course. If you put the spring on now, you'll have to change the spring later. Springs and heat don't go along so good. Okay.
Why do some companies silver solder that mounting block on? Other than to piss me off.
Yamaha.
Jupiter.
Jupiter. Yeah, you know, it's all 100% about their production. Because they don't have people who know how to solder, and so when they solder the nipple on, they knock the saddle off. So they hard solder the saddle on. And Brent Rossborough is the head of Jupiter's quality control, and he and I've had a couple conversations about things like that. Dude, really? And again, I'm heating away from that nipple, right? I'm not heating, the flame is not headed towards that nipple that I just soldered on. It will come off. I've heard people say that it will. It's never happened to me. And the cool part is if you've clamped your water key on properly, it's actually holding it in place.
Maybe it's silver soldered on for some instruments because I get a lot of kids who use their foot to release the water key.
I always thought that
Pretty tough.
the foot was for pushing out and the arm was for pulling in, right?
So you put a water key cork in the water key when you to line it up, when you put it on, or?
No, it's, you do this enough, no, you do it enough times that it knows, you know it's gonna be there, then clamp it in that place and it stays there. Okay, so that really is done. When I do wiping, and I'll do a little bit of this and then get on with building the other half of this. I use, this is just a regular painter's cleaning cloth, Scott towels. So I'm going to come in, have rinsed it thoroughly to remove all the flux, right? Heating out away from the joint, watch that solder heat dissipate right into it, right? I'm going to leave it alone. Move down over here. Heat this one a little bit, wipe that away, and go somewhere else. And I do this around and around and around until I wipe all through the all through the instrument. That way, I've never thoroughly heated any one joint. I've just brought the solder, the temperature up to the edge of the joint that I want to wipe it away, and I've never compromised that integrity. So.
And with silver slides, or we need silver soldering, I mean soldering on silver.
Oh, interesting. I use Pledge, the furniture wax. Furniture wax, it's a furniture polish. You spray it on the silver first, drop your flux in place, and it preventative, no, it'll still flow under it if you're not careful with your heat. But the Pledge keeps the silver from accepting the solder. And it really does quite a nice
Burn
job.
off. The heat doesn't burn it off or anything.
Oh yeah, it burns it. It burns it, it'll snap, crackle, pop.
But it still stops it.
And it stops the solder from flowing. Okay, you've got inner slides are different lengths, right? The inner slides, the lower one has to go clear up to the tail end of the bell receiver. And so it's a longer slide. So they get cut, and one's longer than the other. There was one brand of Holton that had the exact same length slides, And they were a total pain in the neck because the lower cork barrel was a 4-piece unit that you had to go. So I'm going to look for the really cool centering jigs that are resting very comfortably on my bench. Allied and Freeze have a 3-piece centering jig. Come in and set down inside the cork barrel. And that was a total mistake on my part. They were meant to go in my little tiny box and probably would have put me overweight on the airline coming here, you know. I like to have the slide tube proud of the end of this by just a fraction. And I mean probably 10,000ths of an inch. Maybe 12.
Why?
Huh?
Why?
Two reasons. One, when and by the way, solder will not stick to chrome. You know, if you try and, if you're replacing your slide tubes and there's the chrome plating, you cut them off, you have to remove the chrome. And best that you go on your Google and find out how to remove the chrome. It's a combination of muriatic and hydrochloric acid. And I'm not going to tell you what formula to use because some of them are wacky. And chemicals are cool. It gives me a ledge to solder on. I can set my solder wire right on that. Pull it all the way around. I am holding it centered. It's not as precise if I had the wedges in there.
So do you let the tube still stick out now, or do you push it?
No, it's still stuck out.
Okay.
And I have a triangle scraper. I'm going to come and cut this little spiral right off the end of it, and it's perfectly flush. And I didn't have to chase the solder that was going to go down inside the tube. Right? That little shelf gave me an edge to put it on, and the solder pulls down into the joint. Seriously, just trim it right off with your triangle scraper. Sharpen the triangle scraper, and it comes out flat. One more part. Venturi. And I know I have that. Okay, we'll use the one from tomorrow. The Venturi always stands proud of your interior tube on most of your student line instruments. So your measurement to cut the tube length, you have to put your Venturi in and see where it sits. Take that as your total tube measurement for the length. So your tube cut has to be short by that dimension. All right, does that make sense? Yeah. Okay. Now I'm not going to come trim that off because we cut this tube short. Right? Draw that solder in right at that tip. Wall fluxes, and I wipe it off. It just gives that slight smear of solder around that edge, so that I'm confident that it's sealed. Same deal here. Adjust the span of that. The tip of that Venturi in the outer tube, or the inner tube. Put your wedges in. Solder that bad boy full. Let it cool. Now we come back to this. Slide tubes come in. If there's a marker on the name or something, you have to get it in the right rotation. This one here is one of the old con directors, and so the name tag is always facing out. The Yamaha always faces that way. You pay attention to that so that the next guy that looks at the job doesn't stand there and curse you. Same deal with this. And placement of this tube is, I like to center it in the span of the cork barrels. Okay. Way faster to do this with a bottle instead of a brush. Now this is where it gets a little tricky because we have to solder the flanges. We have to solder both flanges in place and then deal with that thermal expansion. But this one, we have the capacity to deal with that. We're on the solid inner slide, solid outer slide tube and crook matching. We don't have that opportunity. So I'm going to solder both of these. Cool them down. And again, we have plenty of time to cool them down to get them outside the plastic. So really what's left here is the tubes are apart. Come on. This is the critical adjustment. With the slides mounted inside, we're going to set it at this angle. I'm going to touch, not press, but just touch this tube to that inside edge. I want the other tube to sit against this outside edge. Okay? What that's going to do is it allows me this centered span. There's a little bit of wiggle room here. I want that to be centered. So the inner slide should be centered between that span. Come in, touch it like this. It's going to sit there. Here's where the fun part gets. Now we have to deal with this thermal expansion that we're able to control on the other side, down here on this brace. But now we have to deal with it. Solder that bad boy together. Because it's a thicker piece, I want it to cool a little slower. and that's the correct span.
So is it the pressure that you're putting on it that stops the expansion from?
Nope. I'm allowing it to float, right? And so it gets a little bit longer. And this is the cool part. It gets a little bit longer, and with it touching here and here, this tube gets a little bit longer. I solder the joint, it gets solid, and now it contracts, and it gives me my gap. It gives me that fraction, those couple of thousandths of an inch of gap, so that I have that movement between the two. So that's an adjustment that you can make, you know, when the slide's not moving well. Sometimes you have to adjust the span here in that slight downward position like that. With safety glasses on, I've seen these spit clean across the room. They really will spit, especially if the manufacturer left any liquid in there. It'll boil. As soon as the solder gets to plastic temperature, it'll go.
That's another reason why you should be careful about quenching solder, because you can draw water up into the joint, which sets a trap for the next time.
Poor sucker. That's right.
Which might be you.
Safety glasses. But by doing it this way, holding it here, it's up against the outside. That tube expansion comes out, the solder cools to solid and relaxes the length of that tube, and now you have the right length. Then I would go about wiping. Again, the same style of wiping, a little over here, a little over here, a little. And at that point, that's how you complete the assembly. And of course, we're going to buff and lacquer it or finish it however you choose. So reasonably, I've done them as quick as 30 minutes. The more complex ones, an hour and a half, 2 hours. And you got to talk to the people at the counter and help everybody else and do all the other things that we get to do when we fix instruments. So, what questions do you have? I'll actually go to the end of my notes here and see. And there is a picture on the notes of that diagram of. Oh, I know. There's one real critical thing. Super critical. You have to drill a hole. Seriously, you got to drill the hole. What's critical here in drilling the hole is that your drill bit is not extended more than the dimension, the thickness, the diameter of the tube. Because otherwise, you come and put a nice little bump right on the backside. And how many of you have bench motors? So just extend your drill bit enough to go through and drill a hole. You'd be surprised at how many instruments I've had come from the factory that have not had holes. It has happened. So the concept is heat control, and that's the most important thing. Your heat, you want to dissipate your heat when it comes time, especially for wiping. Heat outside the joint. Let the heat dissipate up towards the joint, and when it goes from that dull gray to a bright silver, as the solder changes from solid to liquid, or even into plastic, you'll watch it. It comes right up to the edge of that. Wipe it away, and you've never compromised the integrity of that joint. That's how I can pick this up and do all kinds of things with it while it's still in this state, because I'm never compromising the integrity of the joint.
What's the approximate range that is in the plastic state?
It's about 40 degrees.
40, all right.
35, 40 degrees. How many of you have the fancy pad savers? You know, the shove-its or whatever you call it? They make wonderful wiping tools. They're not so good for horns, but they make wonderful wiping tools. A little spray of WD-40, and it repels the solder. Heat, wipe it away. I can bend it, wipe around corners. You know, bend it in half. These are. I think we have like 15 or 20 of them on the solder bench, and all to varying lengths of burnt. But it's okay to go put it in the in the flame, just go wipe it away. But those are really super cool in your wiping. So any questions? Yes, sir.
Do you use anything to neutralize the flux? Or do you just use water?
We use water with a little phosphoric acid, which is like Dawn dishwashing liquid. Just like 1 drop of dishwashing liquid in that much water. We have a spray bottle and it neutralizes it. We do rinse thoroughly after that. You know, if you're going to leave something overnight, it'll turn green. So you want to rinse, be sure that you rinse away all your flux, because the muriatic acid base in your flux will definitely turn your materials green. Typically, we're going to go straight from soldering, neutralizing, into the buffing room, buff, clean, and lacquer, so it doesn't have a chance to be turn into the ugly green mess. Yes. More questions?
Is there phosphoric acid in Dawn dishwasher liquid?
There is in the United States. I don't believe you guys get it. I don't think you get to have. Yeah. You know, whatever clear dishwashing liquid, is fine. As long as it's, I'm not real keen on the ones that you can't see through, but I don't care what color it is, any of them that you can see through. So.
We get the stuff with the bicarbonate of soda and
Yeah, the baking soda. Yeah, I don't know that we need to go to that much length to neutralize.
we get the dishwasher liquid with that stuff.
Oh, okay. Well, that would certainly. We don't have that. Yes, sir.
Yeah, with any tips for, it's not soldering, but older ones when you need to pull the lead pipe. If a client wants the original lead pipe, they sometimes get a bit attached to certain things.
Oh, yes.
Although, like after
you're talking about this.
Yes. Venturi. After 60 years, there's a whole bunch of moisture that comes up between the wall of the inner tube and the lead pipe.
Yeah.
And when you pull that crud, which I'm probably saying
Schmutz.
wedges.
Yes.
Yeah. Do you have any tips to that?
I have gone to hours and hours of great length to go get those out, including a saw, and go with a Dremel tool and a carbide bit, go down the seam and open the tube to save the Venturi, and it's rotten.
Yeah.
Yes, you get attached to them, life changes. But there is a tool, Allied sells a Venturi removing tool.
Yeah, and when you pull it out,
it
comes out about an inch or so.
Yeah.
And then
and it's all plugged up right in.
and all the crud comes in.
Yeah.
It works with it, sort of thing.
You get to cut it apart. They're the ultrasonics. You can use some ultrasonics, which I'm talking about tomorrow. You can get some of it out. I have had Venturis that literally I've gone and cut the tubes out from around them and reused the rotten mount pipe because they were so attached to it. And I guarantee that if I change the mount pipe, it'll change the way the horn plays. There, 1,000th of an inch difference here or there, and it's going to change the way it plays. So.
With Venturis, the new ones, so like an Edwards instead of 3. What do you recommend? Do you recommend putting lube on the Venturi?
I do.
Yeah.
I use the whatever tuning slide grease is your favorite. I lube them up pretty good. I want the tip of it to fit well. It needs to. What I don't want is I don't want it to get in there and sizzle, buzz. When you play, it'll sizzle right in that slide, so it needs to fit well. Most of the Edwards are going to fit very nicely, but I do lubricate them quite heartily with tuning slide grease, and on the threads. Yeah. The Edwards are a nicely built. Tom Getson does a beautiful job. Yes, sir. No, I thought you had a question. Okay. Any other questions? Yes, ma'am.
Another technician that I work with, when he's applying flux, he will not apply flux to the outside like that at all. He dry wipe, he kind of wipes it on the 2 twice and then puts it together.
Okay.
Have you had experience with that?
Yeah.
Tried it or?
On raw tubes, on raw tubes that I'm gonna be buffing anyway, it's of little consequence. Because when you heat the flux, it boils and bubbles out, so you've got flux everywhere anyway. So I'm not saying it's wrong if he wants to take the time. On lacquer, I do come and get very carefully around that perimeter so that I can minimize the burn spot. If you know, old King lacquer instantly turns black. It'll bubble up and blister right in your face. The new epoxy lacquers, they're pretty hardy. You can solder on the epoxy lacquers pretty well, as long as you're not, you know, using a 62,000 BTU torch and trying to melt the brass. You know, you can solder. I've taken tubas completely apart and back together and not burnt lacquer on some of the epoxy lacquers. But you know, on the old nitrocellulose lacquer is going to burn anyway. And so it just is. Yes, sir.
Once you've got a slide that's coming in for service and you want to align everything, work on the leveling block on the outer slide and on the inner slide. And your very, very last thing that you want to do to get it really perfect, do you use that thing where you use the heat and then you push the inner slide against the other one? Just to get it perfect. Sometimes I just got to release a little bit of tension on one end. When I hit that pop, then suddenly bing, I'm good again.
Yep. If the span is incorrect, or the skew, it could be the span of the slides this way, could be the skew of the slides this way, right? So if either one of those is inaccurate more than what you can flex, yes, you have to heat that joint. And if you have to heat that joint, you have to heat, you know, functionality is more important. It has to.
Is that a common, very final step that you'll do when you're aligning everything?
Yeah, I do.
Yeah.
If it needs to be done, I'm going to take the time to do it.
Not that uncommon really to find that the inner slide doesn't quite match the outer slide.
It's true.
I mean, I was quite surprised. So how come this is not right?
Yeah,
it's actually more common than you think.
It's because the manufacturers don't make them square and straight.
You were talking about that clock of marble that Freeze puts out with the magnets. We've got one of those in my shop and I never use it. I don't like it.
Yeah.
You were saying you don't use it because you don't like it. Why don't you like that?
Because it holds the parts together, and it doesn't allow for that expansion of that center tube. So it holds the part together. The center tube expands. I guarantee that that tube coming back is stronger than the magnets, and now your slide is not parallel. That's why I don't use those.
Do you use bonding wire?
Nope. No, literally, I mount them free like this, and my slides are always.
Would you use bonding wire if you don't have those clamps?
No. No, the problem with binding wire that I have used binding wire. The clamp has enough tension to hold it in place. The binding wire will put your tube out of round, and now what happens is you have the shape of your brace. And I know we're running up against the clock, but I'll draw this for you. The shape of your brace tube like this, on out to the other rest of your tube, and then your tube here. You put your binding wire around, and it draws this edge in, which means that it's tall this way and this way. That solder is stronger than that tube. Now you have an oval footprint on the side of that tube that's out around.
That's character.
So that's why I have not used binding wire for many years. The clamps go hold it in place, doesn't put the tube out around. The solder is stronger than that tube, and so as soon as the solder cools, you take the binding wire off. It is oval because it was soldered that way. Yeah. So that's why I have not chosen the binding wire. Yeah. Yes, sir.
One last question.
Please.
What is the secret of the flex home? How does this, every time I've used this thing, it's horrible. What's the story?
I choose to not use the flex home.
Me too, it's the worst thing I've ever spent money on.
There are some people that think that it is the absolute best thing that they've ever done. I typically, my clients are not going to want that feel.
It's horrible.
I used it once, Dirk, when I started like many years ago, and I only used it once.
Yeah, I thought this was,
Yeah.
I thought this was gonna be really great and give me a mirror beautiful finish.
Yeah. Yeah,
It's the worst thing, I cried.
It is not intended to give you a mirror finish, it's actually intended to give you a crosshatch finish.
And then you've got to polish it out on the inside.
But if you want, I'm not a big fan of the Flex Zone. Craig is a really, Tom Getz and Craig Anderson, they're really good friends of mine. They are thrilled with it, they do it all good. I don't buy that one, so.
Could you just speak really quickly about what you do to polish the inside of a sled?
Oh, yes. We have.
And we're out of time.
We have a process to remove the calcium, the buildup of the hard calcification or copper oxide that grows on the inside of the outside slide. We go through a process where we use a Scotch-Brite on a trombone cleaning rod to go address those specific things. After we do ultrasonics, the ultrasonic will loosen it. We'll go do some Scotch-Brite if necessary on there. Then we have a wicking tape. That is, we use the 3/4 inch wide wicking on a trombone cleaning rod, and it's snug. I mean, it's really snug, and it's wound up tight for about 4 or 5 inches, and then now it's the small size of the trombone rod back to the back. We put it in the bench motor, and we actually buff the interior of those slides. Now,
Do you put buffing component?
I do. I use Triple I. The Triple E on that. You get much finer than that, and the surface is too smooth. There is a point where it becomes too smooth. So we use Triple E on it, and we will go buff the interior. Now, safety. Your bench motor is spinning at 1,725 RPM with 3 feet of steel and rod hanging out the end of it. Please don't turn it into a propeller. Okay? So when I instruct my staff, there's always one hand on that rod. Your step on the motor, there's always a hand on that rod, holding it, and it spins. It's not going to hurt you. As you go in, wear a glove. It's going to get hot. Now, if you're really slow, it's going to turn your solder loose. So don't go that slow. But step on your bench motor, insert it. I do want it snug. I want it to actually go in and buff the interior of that. We don't want it so tight that it expands the tube, right? So this is all stuff to consider. But that is how we clean that the interior of that slide without the Flex Home.
I'm offering free postage on almost new Flex Home.
I'm sure there's somebody who'll take that part. Any other floor comments? Last question.
How do you round out and out of slides?
How do we what?
How do you round out and out of slides? So I've seen a few times where they've had their work done years ago or whatever. The outer slide is no longer round. It might be out by anywhere between 4 to 12 thou.
Say.
Okay. 312.
Here's how you do that. Whatever the country code is for the United States, 800 345 Craig Anderson at Allied. Send me a new tube. No, you can round them out, and there's I do it by hand, where I'll come in and set the tube in and come in and flex them this way, find the out of round spot, give it a squeeze. There are other tools. There are Vota makes a nice tool, the roller thing. Don't make your slides longer. They will lengthen the slide if you pull too hard. That's, everything that we do to these is changing the original molecular structure, right? So you have to consider that in your repairs. We still have to make the instrument work. And if it requires changing it, then it requires changing it. We have different dent tools. The nose picker is what they're called in the United States. It's a specific shape. Looks like looks like your thumb. That comes down to the interior. You can lift and squeeze and do. There are burnishing rings and tools, and that's the craft. But
that's a whole, a different class. And we are out of time.
If
One more question.
if you are doing that, if you are trying to get a tube out of, back in the round, you must use a micrometer. Verniers are useless. And micrometers is the only thing that will give you a true feel of the size and you get a good at the time anyway.
Anyway, thank you very much.